Hello there. In this video we're going to solve a trigonometric inequality. And we're going to do that using our old Unit 2 strategy of graph, algebra, analyze. Gah! Okay, so first thing to do is we need a graph. The period is 1. I want to see more than one cycle, so, or the period's not 1. The b-value is 1. P-value is 2 pi. So do a cycle in 2 pi, and I want to see a couple of those cycles. So there's my x-axis. Now let's put in the midline, and establishing that period, or the amplitude. The amplitude's 3, so we're going to start 3 above the midline. That's cosine, so at 0 we're going to be at full extension. We're going to be up there at 4, 3 above the midline. And that's going to return to that maximum again 2 pi later. Boom, boom. Halfway in between those maximums is going to be the minimum. That's going to be 3 below that that midline. So we'll be there, there. These are at -2. Boom. And halfway in between these, we're going to have our midline points. So I'll put in the tick marks there for pi over 2. You don't have to label all these. Eventually that clutters up the axis too much. But we're going to get midline points all along these locations. Boom, and then actually backwards, that's going to be down there. And then we try to connect these. Okay, so there's our cosine wave. Now what we want is for this to be greater or equal to 2. So I'll put in that line there at 2. So that's what we want it to be greater than or equal to. That's y equals 2. So the area that we can see that we're going to be interested in is we want this curve to be above that line 2. So it's looking like that's going to be here, 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 etc. So now we need to do some algebra and inverse trig to figure out what that x location is. Like that point there, when we drop it down, where are we going to be exactly? So we're trying to figure out the intersection, so let's set it equal to 2. We're trying to figure out where these points are, so where we are here and here. Subtract 1, I get that. And then dividing, we get cosine x equals 1/3. Okay, here's the thing. Cosine x equals 1/3, this ratio, 1 to 3, that's not one of the triangles we're familiar with. That's not a 30, 60, 90 triangle. It's not a 45, 45, 90 triangle. So we would have to refer to our calculator and use inverse trig to figure out that one. It's not going to be a nice number. So we'll do the inverse cosine of 1/3. This is the same as the arc cosine of 1/3, and that gets us that x is about 1.23. And note, this is 1.23 radians. So we could convert that into degrees, but the axis here is not in degrees, so we want to keep it in radians. This doesn't have a pi symbol by it. That's okay. There is such a thing as 1 radian. It doesn't always have to be in pi. So we're about 1.23 radians. Now, that's 3.14-ish. It's about 1 point whatever that, and a little bit over 1.5. So we expect that to be 1.23 right around there, and that looks approximately right. So actually we could label that point there. That's about 1.23. But that's just one of them. And if you remember when we did the arc cosine, it's only going to produce, given the domain of a cosine function, we're only going to get angles from 0 to 180 degrees or 0 to pi. So that one's domain is shifted, as opposed to sine, inverse sine, which was negative pi over 2 to positive pi over 2. So we want the other solutions too. And for this you could think about the unit circle. And remember that the cosine of an angle is the x over r. So that x over r, we want that to be 1/3. So here we are going forward 1/3, boom. So it's like there's 1, there's 3, that's that 1/3. And that angle there, which would also be that arc, that's about 1.23. Now we're also seeing it down here. So there's a couple ways to think about this angle. This angle is either the full rotation, 2 pi minus 1.23, or negative 1.23 going back. So we can see that like here, this is negative 1.23, thereabouts, And this one here, that is 2 pi minus 1.23. Okay, so where are our solutions going to be? If we look at the graph here, one of our solutions is this interval from here to here, so from negative 1.23 up to positive 1.23. Another one is here, 2 pi minus 1.23 up to this point, which I guess would be 2 pi plus 1.23. And then we got these over here also. Boom. So it's this interval and this interval and, well, or this interval or this interval or this interval. It's the union of all of these intervals. So let's write out some of those intervals. And they do get hard brackets because it's greater than or equal to. So now I got 2 pi minus 1.23 up to 2 pi plus 1.23. Unioned with this one over here, that upper right one, that was 4 pi minus 1.23. Whoops, there should be a comma there. Plus 1.23. But this keeps going, right? There's more on the left, there's more on the right. It extends infinitely, both forward and backwards, but they're all this distance of 2 pi apart. So we can actually write this in a single notation here. But this is the gigantic union, the superunion, of negative 1.23 plus their 2 pi n apart up to positive 1.23 plus 2 pi n. Hard brackets. And we're indexing that n from, it ranges from negative infinity up to positive infinity. Now this includes the one where n is 0. So if n's 0, that stuff's gone, and you just got negative 1.23 to positive 1.23. Now remember, we rounded that one. And it includes this one. When n's 1, you're going to have negative 1.23 plus 2 pi up to 1.23 plus, or 2 pi plus 1.23. And when n is 2, you're going to have this one over here, 4 pi minus 1.23, 4 pi plus 1.23, and it just keeps on going. You keep on adding 2 pi and you get further to the right, but we also have the negatives. You would get all the ones over on the left, and you would have that entire collection, union of intervals. All right, thanks for watching. So that was our graph. We graphed the thing, we did the algebra here, got those solutions, and we analyzed where do we need to be, and it was a collection of a whole bunch of unions, and we had to use this notation to express that. All right, thanks for watching. Kirkern Scholarship for Life.